afternoon, guys. Let's do the review for our test, which is tomorrow. We're talking about chemical reactions. And the first part of your review has to do with writing the formulas of the following chemical compounds. Okay, one thing that stands out is the Roman numerals. Remember, Roman numerals gives you the charge of the cation in front of it, so iron has what charge in this case? Plus 3, and chloride always has a charge of -1, right? So I have Fe 3 and Cl -1. How many chlorines do I need to satisfy my
4.
my iron?
Wait.
So I need to multiply -1 how many times? 3 times. 3 times -1 gives me -3, and it balances out to +3, right?
Yes.
Alright, the next one is ammonium phosphide. Ammonium is a polyatomic ion. You do need to know this, even though you can use your polyatomic ion sheet. Ammonium has a charge of +1. And I have phosphide. Phosphorus has what kind of charge traditionally?
Great success.
Phosphorus has a charge of -3, right? So I have a +1, -3. How many positive ones do I need to have to balance out my -3? Okay, not 2. Remember, phosphide is P, and P is -3, so I need 3 times. 3 times +1 will balance out my -3. You're multiplying here. Bromine pentachloride, so this one is my covalent, this one is my covalent, this one right here is my ionic, and ionic. So covalent right here, bromine pentachloride is your Br, chlorine, Cl5, bromine pentachloride. The next one is sodium nitride, Na for sodium, and then I have nitrogen. Nitrogen has what charge? Again, traditionally nitrogen is -3, traditionally sodium is +1. How many +1s do I need to balance out my -3? 3, so Na3N. Alright, the next one, manganese 2 chlorate. Manganese has what charge?
2.
Yeah, you just look here. When you have a Roman numeral, you don't have to think, okay, so this is +2, right? All my metals have positive charges, and chlorate, ClO3, is in your polyatomic ions, and just so you know, it is -1. So I have Mn, and then ClO3. I just need to know how many of each do I need to have. Manganese is +2, chlorate is -1, so how many do I have? How many do I need, rather? This is 2, this is -1. I need 2, right? Because 2 times -1 will balance out the +2. Thank you. Is this clear so far? Half of this will be on your test in half of these types of reactions. You really, really have to go over this review. All right, go ahead, move it up for me, sir. All right, and we'll move it down rather, right? So we finished 1 through 5. We are now doing 6 through 10. All right, PBO. Anything that has a Roman numeral here needs to be. Anything that has a starting instead of a Roman numeral. Lead. I don't know what lead is, right? It's a transition. So I know oxygen. What's my oxygen? -2, right? Always. So therefore lead has to be what in this case? +2, right? So it balances out. So you write down in English lead, and then what do I put down? What? 2, thank you. Roman numeral 2. Thank you, Matthew. And then oxide. course, this is going to be my ionic. This is ionic. This is covalent, ionic, covalent. The next one is another lead, another oxygen, but this time I have two oxygens, right? Richard, what is the charge of oxygen?
Isn't it like 2?
-2.
-2. -2 times 2 is
4?
-4, and this is +4. So see, lead has a variety to it. It can do different, it can multitask. It can be lead +2, lead +4, lead, in this case, Roman numeral what?
4.
4. Okay, next one. Bromium selenide. How many it's a covalent molecule. So I tell you, in a covalent molecule, you have to tell me exactly how many of each do you need. How many bromines do you need?
2.
2. So how do I write that down? 2 is what in Latin? Di or bi, right? In this case, di, bromium, triselenide.
Yeah.
Excellent. Let's look at the next one. It's ionic, right? This one, you don't have to tell me how much it is. Does aluminum get a Roman numeral, guys?
No.
No, aluminum is one of those 3 exceptions. Aluminum has always what charge?
3.
Aluminum is +3, so all you need to write down is aluminum, and SO3 is sulfite. Okay? ITE. The next one, covalent, iodine. Do I say monoiodine or just iodine? Alright, and how many fluorines do I have? So it's mono. Fluoride. Okay, so this is the same thing as above, except now you weave in from formulas into English, into writing them down. Are we done with this?
Sure.
Alright, go ahead, take a picture if you need to. We need to move on. Okay, move it up, Matthew. Okay, it gets a little bit more challenging here. Okay, so I want you to balance them, and then I want you to tell me, are they synthesis, decomposition, single, double replacement, or combustion? Okay, first of all, what kind of reaction is this?
Did anybody ask
Go.
them?
Okay, what kind of reaction is this? I have 1 and I make 2, what is that?
Oh, fusion.
Okay, so this is decomposition, right? B, I have
Oh,
1
never
and
mind.
now I have 2. What about the second one? What do I have here?
Combustion. Nope, I don't know.
Single?
Okay, is it single replacement? This
Yes.
guy kicks out his partner and combines with this guy.
Oh,
And then
no.
this guy kicks out his partner and combines with the NO3. So they both switch
Double.
partners.
So
Double replacement, DR. Alright, so let's go with this one. What do we have here?
Where?
That's
Anytime I have oxygen, CO2, and I create water, what do I have? Combustion.
Combustion.
Okay, let's look at the next one. Look at the next one. What do I have here?
Single replacement.
Single replacement, SR. Look at number 15,
Single replacement.
also single replacement, very good. Okay, so I have potassium, let's use our rep. I have KClO. I have 2 oxygens, 3 oxygens, I have to make them 6. So this gets a 3 and this gets a 2. Okay, that's the only way you can make them the same. Then I have 2 chlorines here and 2 chlorines here, 2 and 2. Then I have 2 potassiums here and 2 potassiums here, and it is neatly balanced. Okay, let's look at the next one. Next one, and I won't have time to do everything in here, but I have lead, Pp, I have NO3, and I have potassium and iodine. I keep NO3 as 1 because it's kept together here and here. I have 2 NO3s here, so therefore I need to have 2 over here. Then, let's see what else do I have. I have 2 potassiums here, so therefore I will also have 2 potassiums here. I have 2 iodines here and 2 iodines here, so my iodine is already balanced. And I have 1 lead here and 1 lead here, so this is balanced, and now your equation is balanced. Okay, are you with me? Alright, go ahead and write this down, please. This is all I will do on these because they take up a lot of time, and I really want to go through a few questions on each section, and then we can always come back, okay, if there's enough time. Questions?
Nope.
Okay. Thank you for staying with me. I know it's been a long day, and you guys must be tired. Alright, so this is the same. Let's go to 23, 24, and 26. Let's do at least one. Okay, so here, you're doing the same thing as you did before, except you don't have formulas, you just have the names written out. I can do this one. This one is a little harder. I can do this one. So chlorine, let's start with chlorine. It doesn't give me the state, but it is Cl, right? Chlorine has, is it diatomic or monoatomic, by the way? It is diatomic, right? Chlorine, all the gens, halogen, are diatomic. And then I have scandium, Sc, charge 1, bromine. Bromine is -1, so these 2 are good. Then I have bromine by itself. Bromine by itself is also diatomic, plus scandium chloride, Cl. Okay, let's see what I have. How many chlorines are on the left side? Okay, so I have 2 chlorines in the reactant. I need 2 chlorines in my product side. Then I have 2 scandiums on my product side, which means I need 2 scandiums on my reactant side. 2 bromines, it is balanced. And this is what I want you to do. This would give you full credit. Okay, also you can tell me what kind of reaction this is. This is a single replacement, SR. Okay, so I will ask you about 10 of those on your test. Good? Okay.